What's up, guys? Welcome back to the lab. So another box came in the mail. As we can see, this is the raw state, just unpacked, missing a knob, have some dings on the screen. So we'll see what happens. This popped up on eBay, decided to jump on it. I've done obviously we did a 576 on the channel. This is its little brother. It's a 577. They kind of do the same thing. This is also a D2. This is a non-storage unit. I have a D1 as well. If you guys are interested in seeing the D1 get restored, let me know. I can do a video on the D1 as well. But I'm going to start with the D2. The D2 is the non-storage unit. The D1 actually has a storage display. The other reason I decided to jump on this one is this is the only one I've ever seen that actually has option 10. Now what option 10 is a bigger tube. So I'm really hoping this tube is good. I haven't even plugged it in yet, so I don't know. Option 10 is a 10 by 10 tube as opposed to the 8 by 10 tube. So it has these two extra non-calibrated graticule lines if you need to extend the display just a little bit. So I thought it was a neat piece, so I figured I'd jump on it. The other reason I jumped on it is because I've looked at my D1, and the 177 on my D1 actually has a bad looping compensation capacitor. This control is completely seized on my D1. So I have been looking for a month and a half, 2 months for a 177, which is the control unit. This pops off the front, and I can just put any of them on there. They all work, but 0 177s came up searching for about a month and a half. So this particular curve tracer has a unique tube. I'm kind of curious as to see if this actually is the same tube as in the 576. Don't know, haven't even opened it up yet. One of the things I do know about reading the manual for the D1 is the storage tubes are super easy to burn in, and my D1 has a small burn-in spot. However, this one, we'll have to take a look at it. This is not the storage tube, so the other thing that's different between the 577 and the 576 is the 77 has a screen protection circuit, which will, if there's a static display on the screen and the trace isn't moving, it'll drop the intensity. 576 does not have that. That's one of the reasons why the 576's tubes are so weak. What I'll do is I will get into this one, and we'll see what we find. This is also a real nice test fixture to have. This pops out just like on the 576's. However, when you buy these on eBay, it's usually missing this bar. So having it be a complete unit is nice. So what I will do is, I'm just going to do some basic cleaning on this one. See if I can get some of the chunks off the screen. This does not have a lighted graticule, so it doesn't have the graticule lights or anything like that. So this is just a tube. So I'll work on getting this cleaned up, do some power supply checks, and if the power supply checks out okay, we'll run it through an alignment. I have a feeling it's going to be off, especially missing the knob. It's probably going to be out of alignment. So it wants 30 volts plus and minus 0.75, negative 29.925, or negative 30.075. We'll see what we can do to hit negative 30 exactly. Okay, right now I'm in spec. That's actually a real nice control. I'm going to call that one good right there. We're at negative 30.0 and it's bouncing a little bit, so we are negative 30 to 4 least significant digits. So I'm going to call that one good. Next step is to do the exact same thing with the positive 30 volt supply. I am actually going to take a note here real quick because from reading the document beforehand, they want the supplies to be within 0.5% of each other. So we are at negative 30.000. We'll call it 2. So I'll go ahead and move the supply, and then we'll do the positive 30 volt. Okay, I have moved the test leads. So actually we're pretty good already, but we'll adjust it anyway. This is the positive 30 volt. Am I on the pot? Oh yeah, I'm on it. Now, adjusting these two supplies will decalibrate the entire unit. So the manual specifies only adjust these supplies if you are doing a full cal on the unit, which we are, so. Well, I'm going to go with right there because that is lined up exactly. So, yeah, that looks real well. The next step is adjusting the negative 3,400 volt supply. Okay, here's the back of the CRT. The unit's off while I point this out, and this is a plastic tuning tool because all of the CRT voltages, including the high voltages on this neck pin back here. So the index pin on this CRT is right here. You can tell. I don't know. Let's see if I can get a light to light this up a little bit. Can we see that? Yeah. So right here is the index pin of the CRT. Sorry about all the shadows. So the way you count CRT pins is you start. This is actually flipped over. I'm used to looking at them at the bottom. So if the CRT pin was at the bottom, you'd start here, and then you would count this way. So you're going to start here, and we're going to count this way. So this is pin 1, this is pin 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pins on this. I have to measure this pin right here for the high voltage, and the high voltage adjustment is right here in the top. So, but since I'm expecting a negative 3,000 volts, I did actually have to take a plastic cover off. I'll clean this while it's off. But I took everything off while the unit was cold because I didn't want to short anything out or get buzzed. So I'm going to hook the high voltage probe up so I don't kill the input of my meter. And then we will see what the high voltage supply into the tube is. Okay, just to make this measurement even a little safer, I have the unit's warming up again. The meter's also warming up. I have an alligator clip coming off the CRT pin going into the tip of the high voltage probe. The high voltage probe is clipped to the ground up top, and then that's feeding the meter. One of the reasons why I did it this way is because that allows me to do the adjustment and only have one hand on the scope. With only having one hand on the scope when doing a high voltage measurement, you minimize the chance of creating a circuit through yourself, and especially if it goes through both hands, your heart's right in the path of where the current could possibly go through, and that's not good for your heart. So this makes the measurement even a little bit safer. We are actually slightly out of adjustment on that. No, we're in just barely, because it's saying at the low side it should be 3230, at the high side it should be 3570, and the meter's giving me 3425. Oh, so we're right where we should be. So high voltage actually doesn't need adjustment, but we'll adjust it just to top it off. This has to go into the high voltage supply, so I am using a plastic tool with as much plastic as I possibly can, because I do not want to short out this supply. But we are looking for a 3400 volts. So I'll bring you guys up. We are at 3400 volts. I'm not going to argue with that. 3400.8 on a 4000 volt supply, we're off by 8 volts. All right, so what I'm going to do is I'll shut the unit down and put the covers back on, and then show you guys what it looks like with the covers back on. Just a quick shot of the tube with the safety cover on it. So this plastic piece that the unit's off at the moment is the safety cover. There's this cup that then goes on the back here. I'm gonna clean the inside of this out before I bolt that back on, because I think we're done with the back of the tube. So let me clean that up real quick, and then I'll be right back. And this is the view from the back of the unit with the cover removed, or with the cover replaced, sorry, not removed. So yeah, let me get it flipped back around, figure out what the next alignment point is, and get it warming back up. Okay, so next one is adjusting the intensity range. So what we need to do is we need to take the variable collector to 20%. We need to take the max peak volts to 6.5, which it is. We need to adjust the series resistors to 0.12. So pull that out, turn that over there. Collector supply polarity is AC. Horizontal volts per division is 200 volts collector. Horizontal position is centered. Or that's, yeah, horizontal position is centered. Vertical current per division is 2 amps. Alright. Vertical position is centered, which it is. All light gray buttons are out. All dark gray buttons and knobs in, except step rate and slow. Okay, let me figure out what that means, and then I'll be right back. Okay, and this is what that means. They wanted step rate slow to be selected. All the dark gray buttons should be pressed. All the light gray buttons should be out. The magnification buttons should also be in, so magnification should be off. So then we turn up the intensity to make sure we can get it, and make sure the focus is off. You don't want a highly focused spot. So we turn up the intensity to make, oh, there's a spot. So we can attain a spot. So that was all we were looking for. Turn the intensity control fully counterclockwise, so completely down. So now I need to adjust R1245 for a faint spot. Okay, when doing this adjustment, make sure you're using a plastic tuning tool. Hazardous voltages are right next to this adjustment. It's over top in the high voltage supply, but so intensity is all the way down. We tune this up till we get a faint spot, which there we have a faint spot. Okay, so we need to watch when the trace starts to brighten. So we'll turn this up. And right there it starts to brighten. So that's at the first line marker. Now we need to do 30 degrees. So what we want to do is 30 degrees, which happens to be one panel mark. So that is 30 degrees. I need to readjust R1245 until the spot just disappears. There we go. Okay, so that's the alignment of the intensity control. Okay, we're going to adjust the astigmatism control now. So what I'm supposed to do is defocus the spot, turn up the intensity fully clockwise. It's a good thing this adjustment is short. Find the astigmatism control before you make this adjustment, because you don't want this high-level spot on the screen for longer than required. Need a stouter screwdriver. All right, that's round. Yep, that is actually round. So now what we need to do is we're going to do trace rotation. We're going to focus the beam into the smallest possible spot. Focus is actually pretty good. It's dead center. Set the horizontal volts per division switch to 0.5. Turn this down for a second. Turn this down. 0.5. Now they want us to have 1, 2, 3, 4, 10. They want us to give it some display. This is an absolutely gorgeous tube. The tube is very healthy. So now what we need to do, bring this down to display center. And that should be flat on this line, but it's tilted that way. So we need to adjust the trace rotation. Which for this one is actually conveniently on the back of the unit. Okay, so I got this figured out. This was kind of complicated. So you hook up the meter across a couple of points, and if this is not all the way down, when you hook the meter up to the switch, lethal voltages could be present. Calls that out in the manual. So what we have is we have the spot sign lined up on the center graticule mark. I have to adjust this till the DMM reads 4 volts. 4.001. So we're good there. Now what I need to do is I need to adjust R116 to move the spot half of the remaining distance. Well, I am letting the meter's not 100% stable yet because I had the unit off for a little bit, so I'm going to let this warm up just a bit till the meter stabilizes, because it keeps climbing. So I'll let it warm up, and then once it stabilizes, I'll be back. Okay, I had to do that a few times. So what they're looking for is when the test fixture is centered, you want it on the bottom line with 4 volts aiding, which I have 4.001. They want it right on the top line. So this is slightly out of adjustment, not bad, but that's the effect they're looking for right now. So my vertical gain is back into alignment. So the next adjustment is the horizontal amplifier balance. So let me read through that, figure out what we need to do, and I will be back. Okay, so that adjustment took a few tries to get it right, but essentially what they're looking for is with 4 volts aiding as measured by the meter, which mine is saying 4.001 and 5. It's kind of bouncing. When the output's turned off, the spot should be at the bottom center. When the output's turned on, the spot should be at the top center. It just bounces back and forth, so that lines up the vertical gain. Okay, I have everything set up. I'm going to zoom in on the spot. I had to make a shorting bar, didn't have one. Oop, focus. So we're checking the horizontal amplifier balance. I have the magnifier out to ×10. So what the document wants me to do is rotate the horizontal volts per division control down to 2 volts, and we're looking for minimal shift horizontally from the spot. There's one, that's 10, 5, 20, 1.5, that's 0.2, so it's actually real good. So that doesn't need adjustment at all. So next up is the horizontal amplifier gain. So I'll figure out what that needs, and then I'll be back. Okay, I got everything set up. One of the things that was omitted in the manual was to tell you to bring the spot all the way over here, because if you set up for the horizontal amplifier gain and you don't have the spot all the way over on the left, the gain will push it way off the screen when you do the adjustment. So I've noted on the meter says I'm at 0.00287. So what we're going to do is we're going to wind that up to 502 millivolts. So there we go, and it is supposed to be within 0.05 divisions of the right 10th graticule line. We're right on the line. I'll zoom in here real quick. See if we can get some focus. So we're right on the line, so the horizontal amplifier gain's fine, does not need adjustment. The next step, which is 12, is adjusting the sensitivity correction. It's D1 only. We're working on a D2, so we get to skip that step. Step 13 is adjusting the horizontal compensation. It specifically says not to do this unless it's out of tolerance. Given what's happened in with the other adjustments, I'm actually going to leave that one alone unless it proves to be troublesome later. So that moves us on to step 14, which is the step generator polarity balance pulse 0 and step 0. Okay, so here's the test we have to do. So what we want to do is everything's set up on the curve tracer. I need to adjust the horizontal volts per division to step gen, and we'll see if we get 2 spots on the display. If we get 2 spots on the display, the compensations are out of adjustment. If we don't get 2 spots on the display, skip everything and go to step I. And that's step gen 10x, and we have a single spot, so just turn up the intensity to make sure. Yep, single spot, so we are good there. Everything is all set. So let me figure out what's next. Okay, R455 is a little bit out of adjustment, so what we need to do here is adjust this to center. And there we go. And that brings us back to step 15, which is adjusting polarity positioning. So let me read through that, and I'll be right back. Okay, the centering of the polarity is out of adjustment, so what they want is this dead centered on the graticule. And now when I move this to plus, the spot should jump to this bottom corner, and it's not. It's a little low. So I need to adjust R528 and 570 to get the spot in the lower bottom hand corner. Okay, so 570, bring it up on the screen real quick first, because I know it's a little low. Or maybe it's not a little low. So horizontally, it's actually good. So it's off vertically by a little bit. Almost a division. That pot is not doing anything. That pot may actually be bad. Let me take a look at that real quick. Just make sure I didn't mess up the configuration, and I'll be right back. Okay, I had to play with it quite a bit to get the adjustment right, but now if I take this, the spot's dead center in the graticule, brighten this up just a little bit. If I go to plus, we come down here. If I go to minus, we go up there. So that is now working exactly the way it's supposed to. So I will find out what's next on the measurements, on the alignment, and we'll go from there. Okay, for the step offset, we're supposed to have 1 spot per major division going across the tube. We do. 10 spots. That all looks very healthy. Everything looks good there, so I don't think that even needs to be adjusted, so we're going to leave that one alone. The next one was to test the offset multiplier. So we have the offset multiplier set to 10. We needed a meter reading of 10 volts. We have a meter reading of 10 volts. So everything is good there. Okay, I got everything set up and I've been testing everything. R278 needed a slight adjustment. This is only supposed to come to center, so let's see if I can get it there real quick. All right, there we go. That's good to go. Okay, so we have to reset some controls. Turn this down. Turn the magnifier off. Horizontal. 0.1 volts base. Collector supply AC. Step family rep. All right. that. I missed something. Turn the intensity down real quick. I missed the most important part. Had to pull the actually, I think this is pretty good, to be honest. Nah, it's a little out. So R, what do I have to adjust? R281. I need to compress this just a little bit. Should be a switch and then a pot. Yeah, there it is. I'm going to go with right about there. That looks good. Step family single. Offset 0 is out. Collector supply is plus. Adjusting the DMM for a collector supply of 1 millivolt. No, 1 volt plus minus 1 millivolt. Okay. Had to position the spot to center. Okay, so I have to readjust 281 to position the spot to the center. Yeah, because it was centered. Okay. Alright, 281 again. There we go. Alright, that concludes step 16. So now I need to do step 17, which is adjust the generator output Z. But I need to figure out what that entails. See if that even needs to be adjusted. It very well may not be, because the step generator Z output is working well. I'm seeing it dim and start the display. So let me figure that out, and then I'll be right back. The last step in the alignment procedure for this is to set up 2 resistors, a 1K and a 15K in the test fixtures. I've already aligned the screen, so we're looking at the 5th spot when I turn this on. This is the 5th spot in the vertical. The adjustment we're looking for is when I flip it back and forth, not getting any up and down movement on the spot. So right now we're on the 1K. There's the 15. There's the 1. There's the 15. There's the 1. There's the 15. There's the 1. There's the 15. So the step generator output z-axis did not need to be adjusted at all. Everything was good there. So this actually concludes the alignment of the 577. So what I'm going to do with this is I'm going to put the side panels back on, let it warm up for a little bit, and then we'll do some experiments with it. And I'll kind of talk about why I put in this much effort into curve tracers, because I did end up with a few of them. I had an earlier video on a 576. This is its younger brother-ish. It's still a very capable curve tracer in its own right, but they're geared for different purposes. The 576 is geared more towards power transistors. This is geared more towards logic, things like that, just given the test fixtures. With the 178, you can put VI curves for op amps, things like that. So the power bands are also slightly different. This one has its power band at the low end, where the 576 can deliver all of its power at the high end. So they do a lot of the same thing, but they're not, one doesn't replace the other, is what I'm trying to say. So let me get some of this test equipment turned off, get the side panels put back on here. I'll get some of my test fixtures out, and we'll test some components. Okay, I have the curve tracer moved off of the monitor power supply back onto the regular mains voltage. Everything's working. I have bypassed the interlock, the use your head, heed the warning between the collector and the emitter pins on this test fixture, which is the same for up here, because these are 2-terminal Kelvin sensing fixtures. They have 4 pins on the bottom, so they have CEC sense, E and E sense. Because these are for testing 2-terminal devices, they don't need the base connection. I did find some of the parts from the 5200A repair that we can test out on this, and I can show you guys why I needed one. In this case, I have a 140 volt Zener diode, which was one of the main culprits in the 5200 that blew up. This is a new one, so I can't test 140 volt Zener with any of my meters. They don't go up that high. Actually, for diode testing, the best thing I've got is the DMM 6500, which will actually only go to 10 volts. So I can test the forward, but I can't test the Zener voltage, which is what we need. So if I bring the collector current, or the collector voltage down, we have a spot. It's set to AC. So you'll see a line come out this way and a line go up. Move this up here so you guys can actually see what's going on. So we're over in the left-hand side, and I will zoom in here. So I have the curve tracer set up to 50 volts a division, so every major division is going to be 50 volts, plus and minus. So if we already have a forward, which is what we'd expect, but that's 50, 100 volts, and right there's our Zener. Now the nice thing about these curve tracers is they'll self-limit. So with the main knob here, I have it set to apply 400 volts. Turn this down so I'm not don't have anything exposed. But I can set series resistors, so I can set to 1.5 watts all the way up to 100 watts or more, depending on how I have the series resistor set, because it'll actually let me, on some of these voltages, it will actually let me put in higher series resistors. No, it'll let me go lower than 1500 watts. It won't let me go higher than 100 watts. I think I can show that actually. Yes, I can. So the self-limiting characteristics of the curve tracer. So I have it set to 400 volts at 0.15 watts of power, so 150 milliwatts. But I'll turn this up and you'll notice immediately we don't have that long tail that goes up. I'll change it to 2.3 watts. How we have that tail that goes up even higher. So if I turn it back to 150 milliwatts, the tail doesn't even go up. So it'll tell me what the breakdown voltage is, but that's it. I can spin the collector all the way up, and that's it. It's limited to 150 milliwatts. So when you have fragile components, it'll self-regulate, self-limit, because that's 400 volts applied across the Zener diode, but it's happy. This right here was one of my big headaches for the 5200. This is the 4888 transistor. I still haven't found any of the big pass elements, but this was one of the drive transistors that burn up. This was the unique one that caused me some grief to find. So what I will do is I'll get a 3-terminal fixture. I have the transistor, I marked it as bad, in the socket, and so what we'll do is we will actually turn this to plus. We'll give it 5 microamps per step. Give me a couple of steps. We'll do 5 volts. And we'll set this pretty sensitive to, come on, 100 milliamps of division. So to set up the curve tracer, turn the intensity up, our spots here. We'll give it some collector voltage. Actually, let's give it, let's turn this down to 1 volt per division, and we'll make this real sensitive. So vertical scale is set to 0.5 microamp per division. I'm gonna apply 5 milliamp steps, 5 microamp steps to the base of the transistor. Horizontal supply is set to 1 volt per division. We're on. We just turn up the, oh look, dead short. That transistor is not a transistor anymore. So let me get a good transistor and I'll show you what that's supposed to look like. So this will be fun. I've got it set really sensitive, so I'll just start turning this up. Actually, I'll just start turning this up. And I'll move this up so you guys can see what's going on. Well, this looks kind of weird, but we have a LED in there. It's so sensitive, the curve tracer has actually already detected the forward. However, it's not putting enough current through the LED to actually turn it on yet. So if I turn this down a bit, there goes the LED turning on. give it some more current. Don't limit it to. Oh, it actually shorted the collector supply. There we go. So, if we watch, we'll roll this up. It's the LED. There we go. Right there. So there, the LED's off. Just starting to. LED's on. We'll make it brighter. And as you can see, gives us the current characteristics of this white LED. So lots of uses for the curve tracer. Everything looks really good. I'm extremely happy with the way this turned out. So at least for right now, until I build some more furniture, this actually has a home on the bench. And I'm sure we will be using this often to troubleshoot devices. I have a smaller curve tracer that I use for doing in-circuit testing that I built. It's over there. So as I use that, I'll show you guys how I'm doing with that. And we'll go from there. So I have a problem as I'm given the situation that's going on in the world. I'm cranking through the backlog of equipment pretty quick. So what I'm going to need to do is I'm going to need to find some more stuff to fix. But the next thing up is the 177. No, sorry, this is the 177. The 7603 is going to come back on the bench, and we'll take a look at a vertical amplifier for one of the 7000 series scopes, and we'll go through the calibration procedure on that, and we'll go from there. If anybody has any questions, feel free to leave a comment. I do check the comments regularly, and I will see you in the comment section.